So this is a lesson about different types of variation. This is section 3.8 from our textbook, and we're going to start by looking at direct variation. We're also going to look at inverse and joint variation, and we're just going to look at how to set up the equations, and I'll go through a couple of examples with you. So let's start with direct variation. So the definition of direct variation: when two variables are related in such a way that the ratio of their values always remains the same. So you've actually seen lots of types of relationships like this. You probably just don't recognize it yet. But if I show you a table like this, you can see that as x grows, y grows by the same ratio. So 2 times 12 is 24. 6 times 12 is 72. We can see that the ratio of these two variables is that they grow up by a factor of 12. So the equation would be y equals 12 times x. And this is a graph of this function. Direct variation, you're going to have variables that look like y equals something times x, and it's always going to be a linear relationship since the ratio is going to stay the same. So a formal definition here for direct variation: y equals k times x to the n, or sometimes y equals just k times x to the first power. And this coefficient in front, that's called the constant of variation. That's that ratio that stays constant, that tells us how x and y change relative to each other. When you see two variables that are in direct variation to each other, or you see an equation that looks like this one, then we would say y varies directly with x. So now that we have a definition for direct variation, let's take a look at an example. If y varies directly as the square of x, and y equals negative 54 when x equals 9, find k, and then the value of y when x equals 6. So a couple of things to notice in this problem. The first is that in this problem, they're telling you that y varies directly, and they're also telling you it varies directly as the square of x. So when I set up my problem, I need to be familiar with the form of the equation that represents direct variation, and that's y equals k times x to the n. In this case, it's y equals k times x squared. So the first part of the problem is always going to give us enough information to solve for k, the constant of variation. So they're going to give me x equals negative 54. Y equals negative 54 and x is 9. And then it says to solve for k. So the beginning of the problem, I always want to start by solving for the constant of variation. I should have enough information in the problem to solve for k before I move forward. So I'm plugging in y is negative 54 and x is 9 and solving for k. And when we simplify this fraction, we get k equals negative 2/3. So now that I know what k is, now I know that y and x vary with a common constant ratio of negative 2/3. So y is negative 2/3 times x. As soon as I know the relationship between x and y, now I can use it to work out the second part of the problem. And that is find the value of y when x equals 6. So I have the equation y equals negative 2/3 times 6. And when I solve this, 3 goes into 3 and gives me 1. 3 goes into 6 and gives me 2. And I end up with y equals negative 4. So another type of variation that we're going to look at in this section is inverse variation. So remember, last time with direct variation, it was the ratio that stayed the same. This time, what's going to stay the same is the product of the two variables. So what happens when you have a constant product is that while one variable increases, the other has to decrease so that the product can stay the same. So let's look at these guys for just a minute. Here's 2 times 12 is 24. 8 times 3, 24. 4 times 6, 24, and so on and so on. And you can see that because the product has to stay the same, as the x values are going to get bigger, the y values have to get smaller. If you graph one of these, it becomes a rational function, and we've spent a lot of time in this chapter looking at rational functions. So even though we could write this as x times y equals 24, most of the time when you see this type of variation, instead of being written as x times y equals a product, it's going to be written this way. And that's really just convention, because most of the time when we have functions or equations, they're written as y equals. So a formal definition for inverse variation is here. K, the constant of variation, is equal to the product of x to the n times y. And then again, because convention, or I don't know, just what we're used to seeing y equals something. So just out of convention, we might see this written as y equals k, the constant of variation, over x to some power. And when we have inverse variation, we say y varies inversely with x, or with x to the n. So an example of inverse variation might look something like this. Suppose y varies inversely as x, and y equals 3 when x equals 4. Find k, and then the value of y when x equals 15. So, like the problem that we did before with direct variation, we want to start by setting up the right kind of equation. And the equation that we're looking for is an equation that shows an inverse relationship between y and x. So we know that that should look like y equals k over x. So the next part of the problem is going to give us enough information to solve for the constant of variation. So y is 3 and x is 4, and we should plug those in and solve for k. Once we know what k is, we now have the relationship between x and y. We now know that y is equal to 12 divided by x. In the second part of the problem, it asks us to solve for y, or find the value of y, when x equals 15. Since we know the constant of variation is 12, it's easy to plug in 15 for x. Oops, let's plug in 15. And solve for y. And when I simplify this, I get divide the top and bottom by, oops, not 4, but 3. And this simplifies to 4/5. So we get 4/5 as an answer. Okay, the last type of variation that we're going to look at is something called joint variation. Joint variation is really the same as direct variation, but it involves two or more quantities, or two and more variables that change. So in this case, joint variation is going to look similar to direct variation but involve more variables. So a formal definition is y is equal to k, that's our constant of variation, right, some coefficient, and then x to the n times z to the n. You also could have more variables here, so you might even see something like p to the n. There's no limit to how many variables can be involved in joint variation. So that coefficient k, that's our constant of variation. When we have a situation where one variable is changing jointly with other variables, we say y varies jointly with x to the n and z to the n, and p to the n, or however many other variables there are. So let's take a look at an example of how we would set up and solve a problem that had joint variation. Suppose y varies jointly as x and w squared, and y equals 12 when x equals 4, and w equals 6. Find k, and then the value of y when x equals 20 and w equals 3. So again, I want to go back into this problem, and I want to look for the language that's going to tell me what kind of equation to set up. So here I find that this says that y is varying jointly. So varying jointly is going to look like this. So y equals k, the constant of variation, and then it varies jointly with x and w squared, and I get that right here from the problem, w squared. So I'm going to go back into the problem. I'm going to try to find enough information about the rest of the variables to solve for k, the constant of variation. So I'm going to plug in 12, 4, and 6 for y, x, and w, respectively. And when I solve, I get k equals 1/12. Okay. So now that we know what k is, we know that the actual relationship is that y is equal to 1/12 times x times w squared. So the second part of the problem says, now that you found k, find the value of y. And it's asking me to find the value of y when x equals 20 and w equals 3. So let's plug those in here. X equals 20 and w equals 3. So this is 9. So let's see. 4 goes into 12, 4 goes into 20. And 3 goes into 3, and 3 goes into 9. And that leaves me with y equals 15. And that is my final answer. So we've looked at 3 types of variation: direct variation, inverse variation, and joint variation. They each have their own kind of individual equation or setup that you're going to need to be familiar with, and then you're also going to need to be able to solve word problems involving these 3 types of variation. So I'm going to ask now that you spend a couple of minutes working through some practice problems, and namely you'll be working on worksheet 3.8. One of the first things that it's going to ask you to do is to practice writing those statements, or being able to speak to what kind of variation you have based on the way the equation looks. So let's look at problem number 1 together, and then you'll do the rest on your own. Write a statement of variation relating the variables of each equation, then name the constant of variation. So for number 1, this really doesn't look much like anything of what we've worked with. So one thing that can be helpful for this problem is to just move some of the variables around until it does look more familiar to you. In this case, I'm going to go ahead and multiply both sides by y. When I do that, I get minus x squared equals 3y. And now I'm going to divide both sides by 3. And finally, I get this. Y equals negative 1/3 x squared, or if it helps to write it this way, y equals negative 1/3 x squared. And this to me looks like y equals some constant times x squared. And that means that y varies directly as x squared. So where is the constant of variation? The constant of variation lives right in front of x squared. It's the coefficient, and therefore k, the constant of variation, is negative 1/3. Okay, guys, a couple of reminders for the rest of the week. You're going to finish your worksheet today. You're going to finish your study guide. Okay. And you also have some homework in your book, which the sub will give to you. So make sure you do the review problems out of your book as well, and be ready to turn those into me on Wednesday. Your quizzes are graded. They're on School Loop. Please check out your scores and come see me Wednesday morning if you'd like to go over your quiz with me. And also come see me Wednesday A period if you have any other questions about the lesson today or the worksheet or the study guide. And make sure you study up for your tests so you can do really well. All right, good luck, you guys. See you Wednesday.